Okay, hello. So I'm going to review question 2 in homework 2. Most of you have done pretty well, so I have nothing much to say about your answers. But let me tell you some additional lessons you can learn from this question. So first, in theory, in econometrics, we defined endogeneity as the correlation, non-zero correlation between a regressor and the error term. So that's theoretical definition, but of course, that's not how it is understood in applied economics. In applied economics, we usually think of an omitted variable to see if there is any endogeneity or not, because, of course, like intuitive argument cannot be made based on the correlation. We don't know what is correlation. But so for example, in this case, in the education literature, unobserved ability is the typical example this is the reason why we have to worry about the endogeneity. So of course, as a result of this omitted variable, you will have non-zero correlation. So non-zero correlation is just theoretical output because of omitted variable. So in your dissertation, as I said, endogeneity is the single most important issue in economic data analysis. And then to understand the endogeneity in applied economics, omitted variable is the standard way to argue whether there is endogeneity and how you can control that. And so in question 1, we think about measurement error. So that is another source of endogeneity, you can argue, but that's very specific. That holds only in a very special case. But omitted variable can happen in almost any case. So you have to think about what kind of variables you want but could not observe. So when you do your research, you have to think about that, and that will be the source of the endogeneity. Depending on the literature, also you may think it as a confounder. So in typically causal inference literature, confounder has a similar role, but you may understand confounder as a kind of omitted variable bias. It is not observed, but it affects the error term and your regressor at the same time, so causing correlation, right? And then, so when you do your research, you have to worry about if any variable is omitted. A variable is important in your analysis, but it's not observed. And then if so, you have to think about if it's it causes what kind of endogeneity. So show that there is endogeneity because of the omitted variable. And then you can show that the misspecification bias arises in the coefficient. And then even if you don't know, you cannot identify the true parameter, you can guess the sign of the bias. So you can tell whether you are overestimating or underestimating. So that's typical process you are going to do in your research, your data analysis. Okay, so I'd like to again say that this is relevant to your research, to your dissertation. Algebra is less important. Of course, algebra is important, but that's not a big problem in general. But understanding the intuition behind it is the most important thing you have to learn from this course. And another lesson I want to tell you here is that, by the way, the name of these equations, combining these two equations, we call them a triangular system, because, say, A affects S, and S and A affects Y together. So, it's like triangle. So we call this triangular system. That's the term used in the literature. But anyhow, what I wanted to tell you here is there are Y, S, A, epsilon, U. There are 5 random variables, but actually the underlying variables are these three. Y and S are determined by the other variables. So like say, if you know A and U and those parameters, then you can fully recover S. So you have the full information about S if you know A and U. Similarly, if you know A and epsilon and U, then you know how Y will be determined, right? So Y and S are endogenous variables because they are determined by other variables by the model. Okay, so then, as I said in question 1, assumptions are imposed on the underlying variables, the exogenous variables. So basically what's beneath this model is only these three variables. So you have to think about how these three variables are generated, and we assume these. Similarly, when you derive the bias, then your bias should be represented in terms of only these three variables and parameters. So if your bias includes Y and S, something is incomplete. So that's incomplete answer. So as you see here, it depends on the bias, depends on A and U. Both are exogenous underlying variables, even if they are not observed. Okay? Because anyhow, it is theory, so whether you observe it or not is not important in theory. You can derive it, right? Okay, that was the second lesson I wanted to show you in this question. And the third, and maybe the most important lesson, is this result. I'm not certain if you can notice it, but actually this is very surprising result. So to identify beta, what's important is the error term. Usually we think error term is a noise, useless part in the analysis, but actually not the case in this triangular system. Because intuitively speaking, so remember, beta 0 is the ceteris paribus effect of S on Y. So that means if you can fix the ability and if you can increase education by 1 unit, then Y will be affected by beta 0. Its change in Y will be beta 0, right? So the key point is fixing A and changing S. That's the source of identification for beta 0. And that is possible if you look at this equation now, then it's clear. If you fix A and change S, that is possible only when U increases. So A is fixed. Then how can you increase S? By increasing U, right? So variation in U is the ceteris paribus variation in S, right? So this is the controlled variation fixing A. So in that sense, what matters in identification of beta is U. So this is the independent exogenous variation that enables you to identify beta 0. In other words, in other approach, like if you think about the partition regression approach, now suppose that you observe A, then you may apply the partition regression approach, like regress S on A and take the residual, U is the residual, and use the residual in the original regression. Like regress the outcome on the residual will recover the coefficient beta 0. That's the partition regression result. So in that sense, beta 0 will be identified using this residual from S, right? Okay, this intuition is very important and will clearly show where the identification is coming from. So I want you to understand this. By the way, this doesn't mean beta is identified. So it is theoretically you can show this relationship, but it doesn't imply identification because U is not observed. You never observe U. To to identify U, you have to observe A, right? If you observe A, then U is just a residual, which you can calculate. So then you can identify this way, which is the partition regression result. But in this case, A is not observed, so U is not observed. So you cannot identify beta using this equation, this formula. Okay, so your answers are good. So I don't worry too much about your algebra. By the way, I made my answer based on last year homework. In last year, I had another so this year I had only 4 questions, but last year I made 5 questions. So I made answer on a question that does not exist. So wasted my time. But if you are interested, you can just read it. In the next video, I will discuss question 3. Okay, thank you for watching.